go through the solutions to the questions that I gave you on chapter 4 and 5 on Edmodo. So you were asked there, you got the table of data for 3 gaseous hydrides, and you were asked to determine the type of bonding in arsine. So arsine is ASH3. So you need to use your electronegativity values. You know that hydrogen is 2.2, then arsine, when you look it up, or AS is 2.18. So the difference there is 0.02. That falls into your non-polar. It's not polar, non-polar. It's non-polar molecule. So the type of bonding, you would say there, it's pure covalent. What does that mean again? That there is equal sharing between the two elements, between AS and between H. No polar bonds, there's no regions of positive and negative. Pure covalent is your answer for the type of bonding, okay? Drawing a dot and cross diagram then, well, when you look up AS, you see that it's in group 5, so there's 5 electrons in its outer shell, and then you're going to bond that with the 3 hydrogens. So use your dot and cross diagrams like we did before. Predicting the shape of that, well, it's pyramidal. 1 lone pair and 3 bond pairs, okay? Then the next part of that question, they said, which, if any, of the 3 hydrides would you expect to have intermolecular hydrogen bonding? Well, the only one that can have the hydrogen bonding is the ammonia, and it asks you to justify your answer, because you're going to say that hydrogen bonding occurs when hydrogen is bonded to either, okay? Remember our phone, so fluorine, oxygen or nitrogen, and here hydrogen is bonded to nitrogen, so molecules of ammonia will have hydrogen bonding between them, okay? And then finally it said, suggest a reason why ammonia has the highest boiling point of all 3 hydrides. So all you're going to say there is because of the hydrogen bonding. So ammonia molecules hydrogen bond between each other. Hydrogen bonds are very strong, the strongest type of intermolecular force, and therefore ammonia will have the highest boiling point of the 3 in the table. Then the second part of that asked you about phosphine, and it said phosphine's boiling point is lower than arsine. Now, when you look up the value, the electronegativity values for phosphine, you actually see that the difference is 0. So both of these are pure covalent. So both of them have van der Waals forces between them, okay? So you see, you need to think then about the size of the molecules. So 2 things that determine boiling point: the type of intermolecular force and the size of the molecule. In other words, its relative molecular mass. So they both have van der Waals between them. But if you look up phosphine periodic table, if you were to work out the MR of phosphine, well, phosphorus is 31 and 3, so that's 34 for the MR of phosphine. Whereas arsine, AS is 75 and 3, so that would be 78. So AS is a much larger, and it's a much larger molecule. Its relative molecular mass is much bigger, therefore it would have a higher boiling point. Now, the other point that I think you should mention there, apart from the size of the molecule, is phosphine has less electrons, right? So the atomic number for phosphine is 15, whereas the atomic number for AS is 33. Okay, the fact that this has less electrons would mean that the van der Waals are actually weaker. So 2 points to make about that, right? The size of phosphine is smaller. The MR is 34, whereas arsine is 78, okay? And the other thing is, the number of electrons in phosphine is much smaller as well. And therefore, if there's less electrons, then there's going to be weaker van der Waals forces. Okay, so that was that question 1. Now, question 2, there it said that you had a dipositive ion, M plus 2. Okay, and it told you that the ion has 25 electrons. All right, now if that ion has 25 electrons, what happened to the atom M, the atom? Well, it's plus 2, which means what? It means that it's after losing 2 electrons. So originally the atom M must have had 20. So if it's lost 2 electrons, originally it had 27 electrons. Okay. So you were asked for the number of electrons, the atomic number, of the M. So that would be the atomic number of M. 27 would be the atomic number, because atomic number is the number of protons, but it's also the number of electrons. And then they asked you to calculate the mass number. Now remember, the mass number is the number of protons and neutrons. Now I told you in the question that it had 32 neutrons, so you just have to add 27 and 32, and you're going to get 59 when you do that. Okay, so 27, 59, that would be the answer there. Now, The next one then, question 3, it gave you an ion again, aluminium plus 2, or plus 3 ions, sorry, and it asked you how many electrons the ion has. Now the atom of aluminium, okay, the atom of aluminium has 13 electrons, but what happened to this aluminium atom to form the aluminium plus 3 ion? Well, if it's plus 3, it means it lost 3 electrons. So now the ion has 10 electrons. Okay, so how many electrons does the ion have? 10 electrons. And then how many neutrons? Well, for the number of neutrons, all you do is subtract the 27 or the 13, sorry, from the 27. Is that okay? So you're going to get 14 neutrons and you're going to get 10 electrons. Okay, so that's question 3. Now, in question 5, there was another calculation where you had to calculate the relative atomic mass for galenium. You know, where they have the 60.1% of the galenium was galenium 69, and it said 39.9% was galenium 71. Remember, isotopes, atoms of the same element, but they have different numbers of neutrons. So you're trying to work out the average. Okay, so how did we do that again? Well, 60.1 is 69 and 39.9% of them has a relative atomic mass of 71. So when you multiply those out there, look, you're getting these values, 2839.2, add them all up, 6979.8. Now lads, that's for 100 atoms, remember? So then you need to divide by 100, so you'll get your 69 AMU, atomic mass units, okay? That's that. Now, the question 8 then I was going to do, okay, you have 0.14 grams of carbon 14. Now remember, the atomic number of carbon is always 6. If the atomic number changed, then it would be a different element. So it's always 6. Now how many neutrons? So step 1, it's in grams. So you must get moles. So 0.1 divided by 14, because it's this variety of carbon, remember. Okay, so remember isotopes of carbon, the mass numbers, you can get carbon in 3 different forms. Carbon 12, carbon 13, carbon 14. So this is carbon 14 variety, so the relative atomic mass here for this carbon atom is 14. So the number of moles works out then when you divide that at 0.01 moles. Now you're asked for number of neutrons. So you need to figure out how many atoms firstly, because the neutrons are inside the nucleus of the atoms. So multiply by that and you're getting 21 atoms. Now how many neutrons in one atom? Look at one atom here. How do we calculate the neutron number? 6 from 14, 8 neutrons per atom. So multiply by 8 to get the total number of neutrons. And when you do that, then you're getting your answer for neutrons. Okay, now finally then the last one that I wanted to do was question 11. So again, look, it's similar to the other question that we had. You're given chlorine ion here and you're asked how many electrons. Well, the chlorine atom has 17 electrons. So what has happened to the atom to form this ion? It's after gaining an electron. So it has 18 electrons, and then subtract to get the number of neutrons. So you're getting